Hey guys, welcome to another video. So today, really exciting that I get to do a topic that was requested in some of my videos previously in the comment section. If that's something that appeals to you and you want me to cover some topics that you have problems with or just want it explained, feel free to drop a comment in either this video or in the video that was requesting for topics. So the series that I have planned for the next 3 videos is simple harmonic motion in the extension 2 mechanics topic. So for those that know, this topic of simple harmonic motion used to be in the 3-unit extension 1 syllabus about 3 years ago, and has subsequently been moved completely to the 4-unit extension 2 syllabus. So you'll see that a large number of past papers that I do before 2020 comes from the 3-unit syllabus. So let's get cracking. So I think it's fair to say, before we start simple harmonic motion, it's worthwhile to sort of summarize some of the concepts and formulae for motion, right? Motion along a straight line, to be specific. So nothing in this series of videos is going to cover resisted motion, right? That is, for those that haven't seen it already, I've done some projectile motion with resistance in separate videos early on. Feel free to hit those up, check them out. I am planning to do some resisted motion vertically and horizontally later on, but for now, simple harmonic. So it's going to be a 3-video series. The first video covers, framework and introductory questions. Second video, I want to show you this special case where it's v squared expressed in v squared. And the third one, simple harmonic motion as it's applied to tides, which is probably the most common application of simple harmonic in questions that you see and can get quite hard. So now let's get started. So motion along a straight line. Now, for those that know, this topic is now usually covered in Year 11 under the rates of change topic. Now, I can go on all day ranting about the way that NESA has proposed for schools to cover this in Year 11. Part of that rant is that when they cover this in Year 11, you only know differentiation and not integration. So if it was up to me, I'll go what we did in the old syllabus and cover all of motion at the end after you do integration. Don't do it in Year 11. It's no point in splitting up the topic. I don't know why NESA has sort of proposed rates of change to be included at that point. It still confuses me to this day. So NESA, if you're listening, can you please recommend schools to not cover this in Year 11, covering Year 12? It makes no sense, right, for it to do so. But anyway, here I am needing to teach my students in Year 11 motion. But I said I wouldn't rant, but there I am. Now, if your school or teacher hasn't really described to you the difference for motion along the straight line between the 2-unit and 3-unit syllabus, they're missing something, right? So let me broadly say that for the 2-unit, 3-unit syllabus, especially in Year 11 rates of change, this is motion, in terms of, with formulas in terms of t, right? Expressed as functions of t, in time. So for example, right, whenever you have x or displacement, right, being described as some sort of, let's say, t cubed squared t plus 4 or something, right? Whenever it's a function of t, that's a 2-unit, 3-unit type of question. Or if velocity was, 3, also t squared minus 1, right? That is a 2-unit, 3-unit quality question. Now, in 4-unit, in extension 2, motion in terms of x, right? In terms of displacement. Now, saying that though, you can have motion in terms of t made harder in 4-unit. That's so everything in 2-unit and 3-unit is absolutely open for use in 4-unit, right? But whenever you see motion expressed as a function of x, it's a 4-unit question. So for example, right, we can have acceleration, right? And this is what simple harmonic is about, right? So you have minus 4x squared, right? Function of x. Similarly, you can have v squared, and I'll write this as x squared minus 8x plus 7 or something, right? You'll see those two cases as classical examples of simple harmonic, and I'll talk about those later. Now, are they always simple harmonic? The short answer is no, but these two examples here are simple harmonic. So what I wanted to sort of highlight is that whenever we talk about motion along a straight line, there is a 2-unit, 3-unit sort of aspect where most of the expressions are expressed in terms of t, right, as a function of t, while in 4-unit, whenever you see it's expressed as a function of x, it is extension 2. Now, with that in mind, a nice little diagram that I like to draw for my students is that whenever you have displacement, velocity, acceleration, right, to get from displacement to velocity and then velocity to acceleration, we differentiate, right? Yeah, so that's the rates of change topic. And then what really then disappoints me in my rant above is that because you do it in year 11, you haven't learned integration, so you can't actually come backwards, right? And integrate and integrate, yeah. So you do that again in year 12. I feel like it's a bit inefficient when you do that because, you know, why not just cover it all at once? If it was up to me, that's how I would do it, but it isn't up to me, and I have to react to the way schools are being taught. So unfortunately, that's the case. Now, the third thing I want to put in, and this is quite important before we begin simple harmonic, is that under the 4-unit syllabus, acceleration, right? Now, velocity is just differentiating x, right? That's easy. Acceleration, you can see it's almost like the second derivative. That is one way to do it, right? So when we talk about acceleration, right, what you'll find in 4-unit, in 3-unit and 2-unit, there's usually just one way of doing it. You differentiate velocity and you get acceleration, right? That is one classic, or actually the only way that's open to you, right? Acceleration expressed as the derivative of velocity. However, in 4-unit maths, acceleration, actually, there's 2 more formulae for you to use. Now, you can go ask your teacher, textbooks to prove it. I mean, I can prove it quite simply, but for this lesson, take it for granted that acceleration can also be d dx half v squared, right? Which we actually access quite readily when we talk about simple harmonic motion. And the last one, which is usually reserved for resisted motion type questions, where we have to derive displacement, it's v dv dx, right? All of these are equivalent, right? You can prove them mathematically that they're all the same, right? And there are questions that basically ask you to prove them, but all 3 of them are formulae that we need to be aware of for acceleration. So the key ones we're going to use for simple harmonic are usually this guy and this guy, right? This guy here usually for resisted motion. All right, now that's a nice little summary of motion along a straight line. Let's get into a little bit of formulae, right, for simple harmonic. So let me just zoom in. Right, a little bit of theory for simple harmonic, just so we can begin. So SHM, simple harmonic motion. Now, for those that know, simple harmonic motion is motion, right, along a straight line that basically oscillates between 2 points, right? You go left and right, continuously, or if it's up and down, right? Basically, along a center point, you move, you oscillate around that center, right? So the formula, right, is always acceleration equals a negative, now some sort of constant squared of x minus the center point, right? That, in a nutshell, is the formula. So whenever a question asks you to show that a particle or object moves with simple harmonic, if you can do it in this form, job's a good one, right? Done. So diagrammatically, just to illustrate, so if I had, 0 there, that's the origin, right? If I had some sort of center being over here, right? X equals c. Simple harmonic motion basically says there's a particle, right, that would basically move left and right on this, but it cannot move past it's moving bounded by the endpoints, right? So this is an endpoint here, right? And this is an endpoint here as well, right? So its motion is basically restricted to moving between here and here. Actually, I'll do arrows to illustrate that, right? Yeah. So moves left and right within that boundary. Now, with that in mind, right, what do we know? There's a few things that I need to put down on this diagram, right? So you can imagine what happens is, as this point moves to the endpoint, it stops, right? There's a hard stop there. Guys, we know when a particle in motion stops, we know velocity is 0. That is key, right? Velocity is 0. That is key. So when you sub in velocity is 0, you can find the endpoints, right? The time it takes to go to the endpoints. And then if you sub that time into displacement, you'll find the displacement points, right? The where, right? Where is it? Where are the endpoints? Sub in equals 0, find time, sub in into displacement. We'll do those questions later. Also, just to illustrate, what happens at the center here? If you think about it, right? The motion basically goes, stops, and then it goes back, right? Picks up speed, picks up speed. The moment it hits the center, the speed is at its maximum, right? Max speed right in the middle. But what happens? You start slowing down. In other words, at this point, something happens, right? Acceleration is 0, right? Acceleration is 0. Because what happens is acceleration here is negative in this case because it's moving negatively. But then at this point, acceleration goes to 0, and then it starts becoming positive to slow you down, right? So what's important is that at the center of motion, right, acceleration is 0. Now, conceptually, that makes sense because when acceleration is 0, I use that to find my maximum or minimum velocity, right? It all sort of hangs together. Now, so what I like to always give to my students at this point, right, is some buzzwords. And by buzzwords, I mean in questions, you often hear things like, you know, when v equals 0, they don't say v equals 0. They say things like at rest. Yeah, they say things like stationary, right? Or they say things like max displacement, right? All of these terms refer to velocity being 0. Now, what about the middle here, right? So this one here is at center, right? This one here, they say, now, when acceleration is 0, constant velocity because there's no acceleration, right? Yep. And also, we know that this is max or minimum velocity, right? Minimum when it's negative, yeah? Now, subtly, right, without talking too much about it, at x equals 0, the words there is at origin. Right? Yeah, and what isn't captured in all of this is when time equals 0, the buzzword for that, initially, right? So whenever you hear these words, right, the highlighted a equals 0, b equals 0, t equals 0, x equal to 0, right, is basically what they want you to use mathematically, right? Now, and just to show you the most common version of this, when the center is at the origin, you basically get a equals to negative n squared x, right? That guy there is when, right, when center is x equals 0, right? Cool. Now, guys, I'm not going to write these down, but there are really common questions, right? Really common expressions or formulae that move with simple harmonic. The most common ones are trig graphs, right? Sine, right, oscillates up and down, right? Goes, the endpoints are the max and the min, right? Cos the same, combinations of sine and cos, sine squared, cos squared, they're all simple harmonic, right? So a very common question is where they give you an equation, give you a function, a trig function, and they go, show that it's simple harmonic. I'll show you some questions like that. Now, and then next lesson, in the next video that I'll do, there are common questions that start with the notion, start with the formula v squared, right? I call it special case. It's not really, it's getting less and less special, more and more common, but we'll do that in the next video. And the last video, we'll do tides, right? All right, that was fun. Guys, that's a lot of theory. Let's hit up a few questions. See how we go, right? So, first question, Sydney grammar. Now, this isn't really your typical simple harmonic in that if I remove simple harmonic for this, it actually doesn't make a difference. It's actually just a motion question, but I thought I'd start there, right? So let's see. Look at the marks though, 5 marks, nice. And particle moves with simple harmonic motion, right? You can see there a trig graph, right? No surprise, because trig graphs oscillate up and down indefinitely. Let's see what we need to find. Period, interval, right? Interval sort of implies endpoints, right? What are the x values that it oscillates between, right? Now here's some buzzwords. A particle begins at maximum displacement. What time does it take to pass through the center of? There's all these buzzwords, right? Center, yeah. First time instead of the word initially, right? No, not even initially. First time particle has speed of that. Okay, I'm just highlighting keywords. Let's get started on this, right? So I'll do it down here actually. So period of motion. Now we know that if x equals to 6 plus 3 cos 2t, the period of motion is obviously determined by that number there, right? Where we know that period is always 2 pi on n, right? That's the formula for it. So then in this case, the period of motion is 2 pi on 2, which is pi. Now, there's no units. Oh, there is here. So I'm just going to use seconds, right? It's not a nicely phrased question because otherwise they would have defined the units in question and not in the last question, right? So pi. I reckon if you wrote pi, you'd be right with that unit. 2. Now, interval. So remember, if it's simple harmonic, now I know that the center of motion here, see how the 6, it's like shifted up, but picture it sideways. Actually, you know what? I'll draw it like this, where this is 0, right? The center of motion here is obviously 6, right? Because it's a cos graph shifted up by 6. And if the amplitude is 3, I know that 9 and 3, right, would be the interval. So without doing much math at all, right, my simple harmonic motion is oscillating between 3 and 9, right? Just by my understanding of a trig graph. So that's why I'm saying for this question, it's not your traditional simple harmonic. It just feels like a motion question. In fact, it feels like a trig question, right? So for part 2, without doing much mathematics, like you don't need to sub in v equals 0 here. You just know, right, from your understanding of a trig graph that the interval oscillates between 3 and 9. Yeah. Center of motion is 6. Amplitude is 3. Easy. Yeah. Part 3. What are they asking me for? Still 1 mark, right? The particle begins at maximum displacement. So it's telling me that my motion starts here. Yeah, it begins. Actually, maybe that's another buzzword, right? So when t equals 0, x equals 9, right? That's really what it's telling me. And what time does it first pass through the center of motion, right? So I need to know, right? I'm going to sub in. So it's basically saying when x equals to 6, what is time, right? And because I'm starting from the top, right? It's basically the first time that I dip down below 6. So let's sub that in, right? And sub that into the equation itself, which is this guy here. I don't want to scroll back up. Let's just use that one. So when that's 6 plus, yeah. And I just want to solve this because I think I can do this quite easily without really solving it. But let's just solve it just to show you. So that's 0, right? And then so 3. So you'll ultimately get cos 2t equals 0. 2t. Now, when's the cos graph hit 0? Hit 0 at 0. No, that's a lie. Right, pi on 2, and then 3 pi on 2, and then 5 pi on 2, etc., because I keep adding 2 pi, right, etc., etc. Now, this question specifically asks you not when are all the times, right, that it hits that passes through the center? It says, when does it first pass, right? So if I divide all my solutions by 2, I get like pi on 4, 3 pi on 4, etc. Right? They don't want these ones, because all it wants is the first time, right? That's really the answer that they want. Does that make sense? So in this question, you're going to get a number of answers because it oscillates, it'll always continually pass the center. It only wants the first one. So take that as your answer, right? Put some units in if you want to, seconds in this case. Yeah, not too bad. Nothing too wow about it. Now let's say, find the first time that the particle has speed. So now it introduces speed, right? Which means I need to go from displacement down to velocity, which means I differentiate, right? So let's go there. So for part 4, I know that if x equals 6 plus 3 cos 2 cos 2t, then velocity, or x dot, whatever notation you want to use, that's gone. 2 comes in front, differentiating cos goes negative 6 sine 2t. And in this question, it says when the speed, or velocity in this case, is 3, find the first time. So I'm finding time. So t equals to question mark. Let's sub that in, right? So when that's 3 negative 6 sine 2t, right? Looks like sine 2t equals to negative a half. Yeah. Now, the notion of speed, right, is, just to be clear, so when it doesn't say velocity, which it basically says it's positive 3. Speed means it can be positive or negative. So what I'm going to do, right, just to cover my base, I'm going to say that the absolute value of v, right, is 3, which means when I solve this, there's actually this notion that it's plus minus, right, which means this answer should be plus minus. Does that make sense? So just be careful with that. I think just want to cover that base, that the speed of 3 can be imply in this case going backwards or forwards, right? So when I solve this, then if I solve it, it says first time. So then when I do plus or minus, I just want to take my lowest number, depending, and I think the positive version there, pi on 6, right, will give me my smallest. Now I'm just going to do one answer when this is positive and when this is negative. You know, I know using my Oscillation central angles of any magnitude that this guy's equal to pi on 3. Oh, sorry, pi on 6. And I know there's other ones. Don't care. I just want the smallest one anyway. Just for completeness, the smallest one when it's negative would be what in the third quadrant. So pi plus pi on 7, pi on 6. When I divided everything by 2, obviously that's pi on 12. This guy's 7 pi on 12. Too big, right? So therefore, pi on 12 seconds is the first time the speed, even though velocity, I know to get the positive case, it would have been negative. The velocity would have been negative, right? Speed is positive 3. That's my answer. Just be careful with these terms, right? Speed here, I suspect, would have been an issue for some people answering this question. Does that make sense? 5 marks, nothing really simple harmonic about this apart from the fact that they tell you it's simple harmonic. It's mainly a motion question, all right? Now, let's move on to a more sort of traditional simple harmonic question from Sydney boys, right? This one here is traditional, right? You'll generally get a question that looks like this, where they go, okay, here's a particle. Show. Now, 2 marks sounds like a lot. Normally it's just 1 mark these days, but show that it moves with simple harmonic, piece of cake. Period, first time, well, let's highlight these buzzwords, right? Period of motion, find the time. Particle first passes through the origin, x equals 0, on its first also. Velocity, when the particle is 1 centimeter from the origin, right? So all of these things, right, just gives us information to sub in. So part 1. Now, remember, if I can show that acceleration is negative n squared x minus c, job's done, right? Job's done. That's what I want, right? I want to show it in this form. So if I start with x, 2 cos t plus pi on 6. Now, don't let the t plus pi on 6 distract you. It's not that bad, right? It's just a linear function inside the bracket. So once you get that, then velocity, if I differentiate this, I know that cos differentiates negatively. That function there, derivative is 1, so it's just be minus 2 sine of that linear function. All right, piece of cake. And then if I differentiate that again, then acceleration equals to becomes minus 2. Sorry, yep, that makes sense. So we just say minus 2. Yep, perfect. Sorry, I had a lag there. I thought there was a number in front. Just making sure. Cos plus pi on 6. Okay, that was much easier than I thought, because look at this, right? The moment you get that, what am I trying to prove? I want x in terms of, a in terms of x. All I've got to do now, and generally this is the case, I just got to plug this guy, right? It's the same as this. I'm just going to sub the value of x back in here. So therefore, a equals to minus x, which is actually in this form, right? Because that theoretically is a equals to minus 1 squared times, I guess, x minus 0, right? Yeah. So therefore, moves with SHM, and I say to my teacher that a equals to minus n squared x minus c, right? Generically, boom, done. Piece of cake, right? Nothing too well about that. There's 2 marks. I'm surprised. This is back in 2004, right? It's sort of like every question sort of gets deflation, right? Sometimes in the past, they attribute a lot of marks to questions that are either new or, in this case, a bit of work. But over time, it's because they got better questions to ask, and they've asked this so many times. In depreciating value, you probably get 1 mark for that these days. Period of motion. Now, we know, and this is really important, that the n in this formula is actually the same n as period of motion. So 2 pi on n, right? So whatever number, in this case, it's 1, right? Yeah, n is 1. Whatever that is, that would help me determine the period of motion. So in this case, it's just 2 pi on 1, 2 pi seconds. Yeah. Done. Right, nothing wow about that at all. Part 3. Find the time, so time which passes through origin, right? So let's write down the buzz stuff that I know. X equals 0, time equals a question mark, right? So I'm going to sub x equals 0 into the displacement formula. Let's do that now. So 0 equals 2, so 2 cos, and this is the first time. Yep, first pass, cool. In the first oscillation, so t plus pi on 6, 0 goes away, so then cos t plus pi on 6 equals to 0. We did in this last question. When's cos equal to 0? Pi on 2. Guys, I only need the first pass. Is that right? So just checking that it's pi on 2. Now, technically, 3 pi on 2 would be there as the next one, but blah, blah, blah. I just got to put that in just in case, because when I minus it, in this case, it's not a problem. Pi on 2 minus pi on 6 is still positive. Time has to be positive. So that's the correct. I only need this one. I don't need this one, right? But sometimes when you minus it over, it might be negative, in which case, yeah, we need something. So guys, on your calculator, pi on 2 minus that, was it pi on 3? Yeah, pi on 3, perfect, that's good. Seconds. Done. Now I don't have vertical space. I'm just gonna shift everything up a little. Maybe what I can do. Let's move this. Fit. Yes, that's perfect. Let's go over here. Great. Number 4. Just cut off. Sometimes it does that. It's weird. There it is. Number 4. Find the velocity when the particle is 1 centimeter from the origin on its first oscillation. Now, poorly asked question, right? It doesn't tell you whether it's positive or negative, but let's assume in this case that x equals to, sorry, use green. X equals to 1, and it's asking me for velocity. Yeah. So I've got my velocity formula over here. Now, this is a 2 marker because it's a 2-step process. X equals to 1. I'm going to sub that into, sorry, I ticked this bit. That's wrong. So for x equals to 1, sub that into here to find time. Once I find time, sub it into here to find velocity. That's really how I go about it, right? Find time, sub it in, find velocity. Two-step process, 2 marks, makes sense. So first one, when x equals 0, right, let's try to find time equals a question mark first, right? So sub in 1 over here. Oh, nice exact values for trig, right? Makes life a lot easier. Yeah, so cos t plus pi on 6 equals to 1/2. Shift cos that, inverse cos that. I think it's what, pi on 3, all right? Now this first pass, yeah, first oscillation. So I'm gonna net the first answer, so pi on 3. Now, technically speaking, I go that guy, and then it's also positive in the fourth quadrant, sorry, for cos. So it'd be 2 pi minus that, so 5 pi on 3. Probably don't need those, but minus pi on 6 over, I get pi on 6, blah, 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 blah. I don't need those, right? I don't need those. So that's my first pass. Got my time. And then if they want me to do velocity, sub that into velocity. So then velocity, therefore v equals to minus 2. Now, so negative velocity, that's fine, right? Sub time into here, right? So pi on 6 plus pi on 6, once again, a nice exact value. Right, that's that. What's that? Pi on 3 minus 2 sine pi on 3, which is, what's that? Minus 2. We're 3 and 2, isn't it? 60. Yeah. Looks like minus, oops, too far. So therefore, velocity is minus pi root 3. Here's my second piece of cake. Guys, I see you do it. Very classical question. Now 6 marks. Used to be in 3 unit in this sort of difficulty, right? Hopefully not too bad. Nice introduction to these types of questions. I really want to do one with sine squared and cos squared, right? Just to show you how to go about doing it. And that's going to be our last question for this video. So let's hit up Balcombe Hills 2016. So a classic question, right? X squared, x equals 4 sine squared, which is still a simple harmonic, but just shifted positively. Show the particle moves a simple harmonic, 2 marks again. I think for this one, it actually warrants 2 marks because there's a bit more work involved. But part 2, find the value of x for which the speed is maximum, right? So speed, and determine that speed. So in this case, yep, let's proceed, right? So part 1, remember, you know, I'll just copy and paste it from this guy here. Right, I'll take that guy. Oh, we even got the 1 there, sweet. So I got x equal to, oops, 4 sine squared t. That's chain rule. So then the velocity, right? The 2 comes down, becomes 8. It'll be sine t, right? Multiplied by the derivative of sine t, which is cos t. Now, some students at this point proceed to get I want acceleration, right? Some students proceed to then go and use product rule. Let's be smart and use, so I'm going to split the 8 into 4 times 2, and then we use double angles, right? Yeah, just easier to differentiate with only one function that we know from our amazing 3-unit theory that is the double angle of sine. So we'll go there, right? Got velocity is that, and then that allows me to differentiate that to get acceleration. Now the 2 comes in front, sine differentiates positively, so that's 8 cos 2t. Now, at this point, you say to yourself, well, wait a second. What am I trying to do? I need to somehow, like in the last question, substitute this guy or find this expression here so I can sub in, right? So then once again, we're going to use our amazing 3-unit double angle formulae. We know that with the cos double angle, there's 3 expressions, isn't there? There's cos squared minus sine squared, and there's 2 cos squared minus 1 or 1 minus 2 sine squared, right? In this question, I want everything in terms of sine squared in this pink box, so I'm going to replace it with 1 minus 2 sine squares, right? That makes a lot of sense. because now I want the 4 there, right? That's really what I'm targeting. So let's see. This becomes, can I ask a favor? I'm going to put 2. Well, let's see if this makes sense, actually. Yep. So I'm just going to go and let's just expand. Let's make our lives a bit easier. Minus 16 sine squared t. Now I want 4, right? So I can see that this is going to be 8 minus 4 times 4 sine squared. Isolate that. That is my pink box. Guys, in which case I'm going to sub x into here, right? And that should give me something that is almost what I got, acceleration in terms of x. Now, the question says, can you please force factorize a negative constant out? So if I force, or not even force in this case, if I go, therefore a equals to minus 4, bracket x was that minus 2, done. That is an expression that is in simple harmonic motion, right? So do I have any spaces? Okay, so okay, therefore moves with simple harmonic motion because a is equal to minus n squared. N in this case is 2, and the center is 2, right? Sorry, let me put C there. Perfect. How's that? 2 marks, right? Nothing, like it's a classic question, classically set. So you know what? I need a bit of space. I'm just gonna move half this question if that's okay. Oops. No, you know what? Let's do this. Okay, cool. Next, find the value of x for which the speed is maximum, right? Speed is maximum. Remember I said to you, if I go back a step here, max speed or a max velocity occurs when x is at the center, right? That is key. So in this question, what they haven't told you, right, but is sort of implied is that if speed is maximum, right, the sort of buzzword there implies that x is at the center. And we know from our work above here, the center is 2, right? So when x is 2, and determine that speed. So this is, once again, a 2-step process. I'm going to sub in 2 into here, find t. Once I find t, sub that into v. Now, I might borrow the expression for v back here, right? Because I'll need it soon, right? I'm going to park that over there. That dot, cool. So I'm going to park that there. Let's do this first. So when x equals 0, t equals to question mark. Going to start there, sub that in. 2 equals to 4 sine squared t divided over sine squared t equals to 1/2 square rooted, right? So then sine t equals to positive 1/√2 and sine t equals to negative 1/√2. Yeah. Now it says speed. So I think technically if I do both and I sub it in, what you're going to find is whenever you do this, right, you're going to find maximum and minimum velocity. But when we talk about speed, they're both the same, just direction. One's plus, one's minus. So you just have to sub the positive one in. So if I go shift sign that or inverse sign that, that's pi/4, right? So I'm probably don't even need this one, right? Pi/4, sub that, right, into there to get the value of speed, right? Because I reckon when you go the other side, it'll be like negative pi/4 or something that when you sub in, it becomes -1. But for now, therefore, the speed is 2 times pi/4, so pi/2. Pi/2 is 1. Therefore, v is 4 meters per second as speed, right? 2 marks, 2 steps, 2 marks, sort of makes sense. Guys, how was that? So simple harmonic motion as a concept, right? Doesn't start off too hard. You just got to know the buzzwords, know the framework. Next week, we're going to see next lesson, we're going to see the special case where simple harmonics is expressed as v squared equals a function x. And then the third video, I'll try to cover tights. Guys, if you like that video, give us a like, subscribe, tell your friends, and I'll see you in the next video. See you later.